We'll continue our discussion on sets by looking at three important terms. The first term is called set cardinality. Cardinality refers to the number of elements in a set. The second term is called equivalent sets. Sets are equivalent if they have the same cardinality. And finally, equal sets. Two sets are considered to be equal if they have the exact same elements. So we're going to begin with an example for cardinality. So we want to remember that cardinality is the number of elements in a set. So our example gives us 4 sets and asks us to find the cardinality of each set. So our first set says that A represents the set of all letters in the English alphabet. Remember that cardinality is the number of elements in the set. So if you were to take this set and you were to list out the elements, you would list out A, B, C, all the way down to Z. And if you did an entire list, how many elements would be in your set? Well, we know that there are 26 letters in the alphabet, so our set would contain 26 elements. Therefore, our cardinality is equal to 26. Remember, cardinality is the number of things in the set. For our second example, we have the set B, which contains the values 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, and 39. What is the cardinality of this set? So in order to determine that, we would need to count the number of values in the set. So as you count, you can see that there are 10 elements in the set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Actually 13 elements in the set. And so the cardinality will be 13. The next one says that E represents the set of all primary colors. So again, think about what that set is going to contain. Our primary colors are blue, red, and yellow. And so what is the cardinality of our set? The cardinality would equal 3 since there are 3 elements in the set. Our final example says that F represents the set of all states in the United States of America. So again, think about making a list of the elements in that set. So you might start with Alabama, and then maybe you do Alaska, and you continue on. If you were to do a complete list of all the states in the United States, how many elements would be in your set? And so we know that there are 50 states in the United States, and so the cardinality is equal to 50. The next thing that we'll look at is the idea of equal and equivalent sets. So I'm going to go back to the definition for just a second. Remember that equivalent sets have the same cardinality, meaning maybe they both have 5 elements or they both have 10 elements. They have the same number of elements in the sets. Equal sets means that they have the exact same elements. So our example gives us 2 sets and asks us, are they equal or equivalent or possibly neither? So if you look at the first one, where we have the letters ROCK in one set and 9573 in a second set, these sets are considered to be equivalent. Both sets have 4 elements in them. So the cardinality of set A is 4, the cardinality of set B is 4, so they are equivalent. They do not have the same exact values, but they have the same number of values. For our second example, we have 1, 3, 5, 7, and 9 in set A, and we have the same exact numbers in set B, they're just in a different order. So these 2 sets are considered to be equal. They have exactly the same values or the same elements in the set. Our next example says that we want A to represent the set of all even natural numbers less than 20. So I'm going to go ahead as we start and just kind of jot this down. So even natural numbers less than 20 would be 2, 4, 6, 8, 10, 12, 14, 16, and 18. And it says B is going to represent the set of odd natural numbers less than 20. So set B is going to have the numbers 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Okay, so what about these two sets? Are they equivalent? They are not equivalent because you can see that set B has one more element in it than set A does. And they're not equal either because they don't have exactly the same elements. So in this particular example, we would simply say that these are neither. They're not equal and they're not equivalent. All right, our last example says that A is going to represent the set of teachers in our class. Okay, so set A would just contain me. So I'll just write my name here. And set B represents the set of students in the class. So I'm going to just make up a few names here for students. Maybe we have Sue, and we have Tom, and we have Bill, and so forth in the class. We'll list out all the students' names. So what about these two sets? Are they equal? Are they equivalent? Equivalent would mean that they have the same number of elements. In the teacher set, there's just one. In the student set, there's many more than one. So they are not equivalent. Are they equal? Do they have the same exact elements? No, they don't. So this is also an example of one that is neither equal or equivalent.